My name is Guillaume. I'm Product Line Manager at Exfo. And today we're going to look at 5G, the first deployments, what have we learned from those first deployments, and look at how to properly test the network to achieve great performance when turning on the 5G services. So just as a starting point, we know that telecom technologies are evolving really at a fast pace to meet the growing demand for bandwidth. All the way from the 1980s with the analog phones down to what we had in the 2010s, 4G with all IP mobile broadbands. And the next step, the next evolution step is 5G, which is happening now, which is more than just extra bandwidth. It brings new possibilities for industries thanks to its enhanced broadband. We think often of such applications such as remote surgery, connected vehicles, high-speed mobility, autonomous manufacturing, and agriculture. So 5G is really taking off. So this is from a European perspective, the different deployments that have taken place per country. So this is map that I've took from Ookla. So it's really good to stay in touch with the state of the deployments. So we see that commercially available 5G services have been rolled out over 15,000 times from different operators in different European countries. This is something that is also expected to continue to grow a lot in the coming years. To illustrate this, here's an interesting chart where we see the number of 5G subscribers, right? So there were deployments, and now the number of subscribers is slowly ramping up. But it's I say slowly, but in fact, it's going to be a steep curve. You see it growing a lot. So from 2020 to 2021. So just in 1 year, we believe that in North America will move from 10 million people to 56 million people, and in Europe from 8 to 38 million of connected people to 5G services. So times five growth to be expected for next year. So really, the inflection point is going to start to come next year for this one. There are tighter key requirements linked to 5G compared to what we had with LTE previously. So those requirements are needed to be able to achieve the performance that we want and to provide the new services that will be enabled by 5G. However, they also raise some challenges from an installation and turn up perspective. And it also means that the test procedure will need to be followed even more carefully than it was for 4G because of those requirements. So first off, the latency needs to be decreased quite importantly by a factor 25 with ultra reliable low latency, less than 1 millisecond end to end. The reliability needs to be increased by a factor 10 to reach 99.999%, and the throughput also needs to be increased by a factor 10. So really tight requirements and challenging ones that the operators will face to enable the 5G services. 5G also brings a greater density of the cell sites. So to illustrate that, here's a chart where we see for a certain location with 4G LTE services, 6 sites, so macro sites were needed to cover that area. For the same area, to give a 5G coverage, we'll need to increase the number of cell sites from 6 to 117. So you need 20 times more cell site to cover the same area to give the expected service meeting the requirements that I've mentioned. So for this, you'll have a mix of macro cell sites at 2.5 gigahertz with small cell sites, so a lot of small cell deployments. You hotspots, also for the small cells, you have some at 3.5 gigahertz and some at 26 gigahertz. But all in all, the idea of showing this slide was to illustrate really the importance of the growth of the cell sites that will need to be installed to give proper 5G coverage. From a physical layer perspective, 5G would need more fiber, right? All those cell sites are covered by fiber. They're linked together with optical fiber. So you need way more fiber to be deployed in order to reach those installations. In fact, this image you see here coming from Corning shows a urban area, so a densely populated areas. You see the difference of what was needed in red to the left for 3G or 4G coverage, while on the right we see in blue the extra fiber that needs to be deployed for 5G coverage. So this is in urban areas a factor 100 in terms of the more fiber that you need to be deployed there. So lots of lengths of fiber, so lots of install to do and testing to do as well to ensure that they are all good and as expected. Why does testing matter in a 5G context? Well, different elements. We know that there are massive scale upcoming deployments. So a lot of deployments, we saw the cell sites, we saw the fiber that needs to be installed. So a lot of deployments, you want to make sure that those are controlled and that testing is properly done to meet the requirements. Also, because of those massive deployments, the operators are often relying more heavily on contractors. So this is a trend that we've seen in the industry for a little while, but it's even more important for 5G. So a lot of deployments to be done, a lot of contractor are part of the equation. Those people need to be, given some targets in terms of the testing that needs to be done, the reporting that needs to be provided once testing is done, and they might not all be experts in telecom testing. So by having good methods and procedure clearly defined and with the clear requirements in terms of the reports, this is also a key element for that. Also, 5G is extremely costly to build. It's time consuming, but also from an operator perspective, you want to deliver the service that you're promising to your customers. There's a lot of competition between the different operators on who will be the one to serve the first 5G service in a certain area. So you want to make sure that the first time you build it right, first time right. The first element to look at from a testing perspective is really linked to the connectors, the connection points. Those tiny little connectors are really the weakest point in the network. You want to make sure that they're in good shape, that they're not damaged, that they're not dirty. In fact, bad connectors is considered the number one cause of network failures, and 80% of the network owners, they report having issues that are linked specifically to connectors, to bad connectors. Why is inspection important? Well, not only because it's nice to have clean connectors, no. Connectors, if they are dirty, damaged, will have a direct impact on the insertion loss, creating more reflectance as well. This in turn will create bit error rates, will impact the system performance and the network reliability. So you always want to make sure that they are in good shape. What can cause those different connectors to be dirty? Well, it's always linked to the manipulations of those connectors. As we said, there's a lot of contractors in the equation, so those people need to be properly trained on how to handle fiber optic connectors. Make sure that they do not touch them. They always leave their cap on. But even then, we often see cases of connector end face that would have dust particle on them, even if they were protected with their protective cap. It's also important to note that the impact is even greater if you have multi-fiber connectors, such as MPO or QDC or OptiTip connectors, where a single bad connector will impact multiple fibers, will impact multiple lengths as well. So this is really the first element to do when touching fiber for your 5G install, making sure that the connectors are in good condition. It's also possible to, the second step is really fiber link characterization, which is needed to make sure that the physical layer, that the fiber is in good shape. This can be done with tools such as OTDRs or IOLM. With this, you're able to validate and map your fiber network, see the overall insertion loss, optical return loss, make sure that it's within budget, But also you have this information for each of the individual elements you have along the link. So each connectors, each splices will be properly identified, located. So you'll have their exact position. You see their loss, the reflectance for each of those individually. You would see other elements such as your splitters that you have in there. If there's a fiber that is too tightly bent, which we call a macro bend, which is another important source of problem, this would be identified. So you know right away from the get-go that the fiber foundation that you need to overlay your 5G services is ready and is good, so that when you'll turn your service up, you won't have any bad surprises and everything will be as expected. The third important piece is the protocol and the equipment validation. So once you know that, okay, my connectors are good, my fiber links are all good, are all mapped, I know their characteristics, then the third step is to validate the protocol layer. So you would validate the CPRI or eCPRI link. So we know that with 5G, we're moving away from CPRI towards more of the eCPRI link. So you want to do that protocol validation before actually plugging the live equipment to make sure that there's no bad surprise, that everything is working according to plan. And you also validate the equipment. So you validate the radio unit to make sure that it's trouble-free, that it will work fine. You can also use it to validate your transceivers to make sure that the transceivers are working as expected and that you don't have any faults there. So you always do this before going live so that, again, you know what's in front of you. It has been tested so that once you turn your system on, there's no bad surprise at this point. So really, this is the three-step process that we recommend at Exfo in terms of the installation and activation testing that needs to be done in a 5G context. So as I mentioned, the first element to do always is fiber connector inspection, and then fiber link characterization. So then you make sure that your physical fiber links are good and meeting the targets in terms of budget. And then the third element is protocol and equipment validation. So those are the three steps to keep in mind when we talk about 5G testing. Here is a use case, a case study that we had. So I'm based here in Canada, and there was a tier one mobile network operator that was planning to deploy 5G here. Of course, they wanted to deploy their services. They had objectives in terms of rollouts, in terms of timeline. They had at the last minute to switch from one equipment vendor to another. And they still have their tight timeline to follow. But then in their use case, they were using distributed RAN architecture with microsites. There was a mix of MPO connectors in there. They were using DWDM as well, QSFP plus. So when they tried to turn it up, uh, only you had 15% of the new sites that were not working. They had issues that were intermittent, and for them it was really worrying because they had those 50% of the site that were not in good condition, although all elements were there, and all pieces of the equipment were there. So we went on site to help them figure out the situation there. So we started to look at the protocol layer, to look at eCPRI, to validate from the ground up what was going on, to do monitoring of those protocol. And we were able to confirm that the link up with the 5G radio, and we validated the optical power, so that was okay. Then we validated with IOLM the fiber. So we looked at from the baseband unit all the way up to the remote radio head to validate, okay, is the fiber good? Do I have excessive loss? And we were able to see that in fact there was excessive loss at the connection point. So again, those connectors, so within that cell tower, you had the mix of duplex fiber and of multi-fiber. They were using the QDC format. So in there with IOLM, we were able to map exactly which connection points were causing problems. Note that there were 7 connection points points from the baseband unit all the way up to the remote radio head. So again, that's a lot of connection points for a short distance, a lot of potential causes of error, potential causes of loss and reflectance there. So with IOLM, we're able to see exactly which of those connection points were faulty. We're able to go there using the fiber inspection scope to inspect them, properly clean them. Then we made sure that all the connection points were good. And after that, before turning it back on again, we validated also the SFPs and the QSFPs in the system to make sure that we're emitting as expected. Some of those were also faulty. So doing this, we're able to pinpoint some faulty optics, some connectors that were not in good shape. Once this is all clean, and the transceivers were changed, we're able to turn up the system back up, and then it was working as expected. So with those testing steps that were done, in this case after the fact, we were able to pinpoint and correct the problem. Of course, this meant that the technicians as well as our own app engineer had to go back on site, so rework extra truck roll, but we were able to find the problem. It's sure that in an ideal situation, those testing steps would have been performed right away from the moment of the install, so that at the moment of the turn up, there wouldn't be any bad surprises. So in this case, the outcome was that this operator used Exfo as the trusted advisor and decided to update their methods and procedure so that the installation steps that I mentioned were all properly documented, so that in the future the contractors that they're working with would follow those steps and methods of procedure to make sure that this thing is done properly according to the industry's best practices. So when they turn up a cell site, they don't have bad surprises like that. We also help them write down their troubleshooting procedure in case they face problems in the future. And the tool that they were using for that was the FTB 5G Pro, which is a kit comprising all the test modules really that you need for a cell site turn up in the context of 5G. So this FTB 5G Pro kit is combining, as I said, all the tests that you need.
Guillaume, we'd have to wrap up because we're sort of out of time.
Okay, so just wanted to briefly highlight this FTB 5G Pro. It combines the inspection test you need, fiber characterization test you need, the transport test you need for the protocol layer, as well as the transceivers. For fiber inspection, we have a tool that was just launched last week, a new fiber inspection scope, fully automated, supporting MPO connectors, single fiber connectors, LC connectors, easy to use, automated with an easy tip switching mechanism on it. So with this, I'll be ready to take any questions the audience might have.
Cool. Thank you for wrapping up quickly. I know we're really late here, but if you could answer these questions really quickly, I think folks will be happy. So let's see, what's the impact of dirty connectors on MPO cables? That's an interesting question.
Well, when you have MPO cables, typically, those are high-speed links. So when you're in high speed, it's more critical that your connectors are good because you have less room for margin there. And also, a single bad connector, would affect multiple links. So in, the example I was giving, if, your link is live and then you see that you have an MPO connector that is faulty, it means you need to unplug multiple high-speed links, which is something you really want to avoid. So that's another important reason why you want to inspect and make sure that they're in shape before turning on the service.
Okay, another question, just a quick answer is fine. Do you think 5G and FTTH, fiber to the home, can coexist?
Yes, I think they do. There's a convergence between the two. And of course, the operators will want to reuse as much fiber as they can from their existing FTTH infrastructure. And the ones that are a bit, late in their FTTH deployments will want to think their network architecture to support both FTTH and 5G to reuse as much as possible of the infrastructure.
Good. And that's there's a similar question to this about deploying similar, having 5G use optical fiber in remote areas, but I assume that's the same sort of answer. I'm going to thank you. That was a great talk.